something relevant for onshore and coastal areas where the possibility of load testing is feasible, whereas for offshore conditions full scale load testing is not feasible because of several constraints. In any case, to understand what involves such load tests will be very useful, so that you can see what alternatives can be worked out for offshore conditions. But in the near shore, around less than 20-25 meters, we have done pile load testing, but quite cumbersome, quite expensive and time consuming. So, the pile load test, if you look at the history of design of foundations, there has always been a debate because of the uncertainty associated with the soil parameters. Always it is understood that design is verified by testing to full scale at the site of the final construction. If you look at many of the international codes, obviously they state that the engineering based design is not 100% sure. So, if you go back to British codes or European codes, including Indian codes, especially for pile foundations, you will see that every pile needs to be tested to its capacity, every pile. So, if you have say in a construction site several hundred piles, testing every one of them becomes is elaborate as well expensive, time consuming. It puts the whole project in a different schedule of construction activity. So, you select critical piles or piles that may represent actual site conditions. So, among 100 number of piles may select say 2 piles or 3 piles which may represent actually the site conditions. So, normally most of the modern day project we take about 3 to 5% of the piles. That means, if you have 100 piles, you do the testing of 5 piles. So, you select them in randomly to distribute all around the site in such a way that you can extract information from this pile testing, so that you can represent them in the design process. But by doing that, what you are actually going to do is you take these so called the test parameters and then back calculate and go back to your design, revisit the design and adjust the design parameters to suit the tested pile information. So, if a tested pile is giving the design or the failure load is lower than the design load, means your design parameters what you have used in your calculations are on a higher side, or vice versa. So, you can go back and then adjust the parameters until that you get the design capacity versus the failure load is almost close by. So, this adjustment is even now many of the projects we try to do this, so that in the future installations become almost reasonably correct. So, that means this testing has to be done upfront before the construction starts. So, that is the idea behind pile load testing. That means, you get a comfortable level of confidence which is very essential for foundation system, because you can't have an uncertainty on a foundation for a structure which may actually pose a big threat. So, the pile load test has been there for several decades for onshore and offshore projects of near coastal areas, several kind I would say. So, since now you see the procedure how we want to start the project with load testing, we want to do the load testing upfront before the actual construction starts. So, you can say sacrificial testing. That means, once you do the testing of these piles, the piles will never be able to use it, because you already have failed the pile to ultimate load capacity. So, that means, you have a different category of testing, or you can actually test the same pile which you want to use it as a part of the structure. That means, you can't fail the pile, but you can actually apply the loading until the load that it may get during its service. So, you can see here now planning is required. What type of testing is planned for that particular site, whether you want to do a full scale failure load test or you want to do a working load test, the test that may actually take you to the level of working load and stop. Then you actually construct the structural system on top of it. So, this pile load test is quite useful in a sense. So, we will look at various tests and the procedure available for us. So, we will be looking at both horizontal load test and vertical load test. We have especially the coastal areas and the berthing structures and offshore structures, we have considerable amount of horizontal load compared to onshore structures. And then we will look at some of the testing, some special testing by which you could actually get the similar information, but then kind of empirical methods. You do some testing and extract the information and prorate it to obtain the actual failure loads, which nowadays seems to be very economical and is quick, especially the dynamic testing, and some of these are commonly used. So, if you select 5% of the piles for testing using gravity method, the remaining 95%, still the uncertainty exists, because if you look at a site, construction site, say 1 kilometer by half a kilometer wide industrial construction, and you select only 1, 2, 3 and 5, remaining 95% of the pile is distributed all around this site. Now, you may conclude based on 5 piles that these remaining piles are safe, we have adjusted the design, but what surety you have over the distribution of soil within a 1000 meters length? It may be a very difficult decision. So, instead you go for the remainder of the pile with a simplified method. Instead of going and putting a big weight and then measuring the displacement and strain, you do a simplified method of prorating the capacity based on certain small scale testing, which is what we use the dynamic testing, and which is very useful. In many cases it proved to be so if you do a full scale testing and on the same pile you do a dynamic testing, compare the capacities, then you can actually get a very good feel how the dynamic testing is faring with regards to the full scale gravity testing and your design, your theoretical design. You have 3 numbers to compare, and then you can come to a conclusion, and then the remainder of the piles you go and do a. So, you can see the correlation is very important from gravity testing to a dynamic testing to a engineering design. Then you go back and then do the remainder of the pile, you have only engineering design adjustment plus the dynamic testing. So, this procedure is adapted in most of the large scale projects, but of course, if you look at only some projects where only 5 piles, 10 piles are there, this subject and the dimensions of the structure is so small, like 50 meter by 50 meter, the variability may not be that great. So, you can do only 1 pile test and you can leave it. And in the recent days, application of such simplified methods for pile monitoring for offshore structures is very much useful, like what we have learned about the numerical scheme to calculate the number of blows required to drive a pile to a particular depth of penetration using a particular hammer. You can back calculate, and that is called a pile monitoring system. That means you will use the information during driving and back calculate what resistance it would have been offered by the soil during driving, and then you just adjust it to long term capacity using several parameters, and then you can predict at the end of driving, you can say the pile would have achieved this much capacity. Now, what you did avoiding here is you are not going to place a big weight and try to do a measurement of displacement, which is quite cumbersome, especially when the pile is very large and the load is huge, and that is why the pile monitoring system is one of the indirect means of getting pile capacity in offshore conditions, and that is what we are going to discuss at the last. And in the recent times, in the last 10 years or so, another method of permanent implant of a device into the pile system, which is adapted for concrete piles at least. Basically before you install the concrete pile, you put a load cell at the bottom of the the concrete pile itself and just cast the pile, and afterwards you have a activation system, a wire will come to the ground. So, you can activate the hydraulics and you just push the pile against the soil resistance, and this can be done for ultimate test or it can be. So, this O-cell test is also employed in some of the onshore projects, bridge projects in US, but very rarely in this part of the world because it is quite expensive. You need to embed a complete load cell inside the pile itself permanently, you can't extract them afterwards. So, it is just left over there. So, this O cell is basically Oosterberg cell, named after the person, the professor who found this method for one of the bridge project in US, and it is in use for quite very useful. Few projects we have used it for offshore or coastal. So, we will go through each one area by little bit detail. So, the purpose of pile load test is to find out the installed pile capacity and to verify the and remove the uncertainty associated with the assessment that you have gone through during boring, taking sample, and then to laboratory test, and then properties and unknown properties are calibrated using past information. So, all those things will be removed once you have the actual capacity versus the displacement. And to assess the load displacement relationship, basically there is no theoretical information that easy to relate the capacity versus displacement. We might have already got the methodology to evaluate the capacity, bearing capacity in terms of end bearing or skin friction. Only thing is we have an assumed load displacement for Py Tz, which may not actually 100% represent a multi-layered soil. What you saw was basically a single soil layer give you a theoretical relationship between the capacity and the displacement. Whereas when you have a multi-layered soil, the behavior itself is going to be complex, and the only way to get the load displacement relationship is to carry out a complete load test, which will be a prototype in nature. We are not doing a scale model like our laboratory. So, the primary purpose is to link and assess the load displacement characteristics of a particular pile at a site. So, the test can be of in fact 3 categories. Basically, the one that normally carry out is the static load test, the load is static in nature, and then the dynamic load test, which is what we were talking about, the quicker and the cheaper methods. Then we have the bidirectional method using OSL. You can actually do this way or the other way. In the static load test, we have got variety of load application methods. One is the constant rate of penetration. Imagine if you have the pile already installed and try to do the loading, the displacement is not under control. So, that means if you go by this method, whatever displacement comes you will actually note down. Whereas, if you actually control the displacement by changing the load according to the displacement characteristics, the rate of penetration can be controlled. So, but the first one is quite obviously very difficult to do, because you have to continuously having a monitoring system of displacement and adjust the loading according to the rate of penetration. Not many of the contractors have this facility, because you need a feedback loop, so that when the displacement increases you have to decrease the loading, and it is only feasible by hydraulic means, whereas normally most of the load test you see in the field they all just put big weights. So, removal of weights is going to be very difficult. So, most of the time we do a maintained load test. You put one weight, wait for several hours according to the procedure and monitor the displacement. If the displacement becomes constant, that means for that particular load soil has achieved its maximum possible displacement, then go to the next load increment and apply the loading, wait for several hours, and vice versa. You remove the loading and look at any the elastic rebound happening, or it is a plastic failure. So, basically this maintained load test is commonly used in most of the projects. Very rarely we go for this particular method. Dynamic load testing, we have very similar idea like the pile hammer. When you take a hammer and drop onto the pile, and you see the stress waves travel through the pile and get reflected if the absorption is not enough, and you measure these characteristics of the transmitted stress wave and reflected stress wave, and depending on the reflection and the transmission you back calculate using the same principle what we were looking at the dynamic equation, and calculate back what would have been the resistance offered by the soil, because this much wave has reflected back from the soil itself. So, that is indirect means, but before going and doing the actual testing at the site you may have to actually do a calibration in a known material, which is easy to do, and after that you can compare with the known material versus actual pile at the site. This is, you got two types of test. One is the high strain dynamic testing, the other one is a low strain dynamic testing. It is just the weight of the hammer, and the low strain dynamics testing is normally preferred, because for concrete piles if you do a high impact the pile itself will actually fail. Pile monitoring, I think we will talk about it little later. This is a simple idea of using the driving information or driving records, number of blow counts, and the duration between the blow, and also sometime you will have the measured stresses at the pile tip at the top, and calculate back the resistance, which is also dynamic because you are using the pile the hammer impact loading. Bidirectional method is quite useful only for the O-cell testing, which is you can do testing in both directions because the load cell itself is implanted into the pile foundation. So, you can do vertical load test, you can do compression, tension. I think obviously some of the piles in coastal areas, for example berthing structures, you will have compression loading and tension loading depending on the magnitude of horizontal load. So, the piles needs to be tested for compression and tension as we calculate the capacities. Pile capacity we calculate using skin friction plus end bearing, that is for compression. For tension you will have only skin friction depending on whether the pile is plugged or unplugged, you will see whether internal and external. So, in this case the tension testing is required for only few number of piles. For example, when you design a structure, the whole structure does not have any tension loading, that you do not need to do this type of testing, but most of the berthing structures will have tension because the gravity loading is very less and it is predominantly going to resist the horizontal loads like ship berthing structures. So, you will see a huge amount of tension coming and you have to make sure that the pile has sufficient penetration to take the tension loading, if not the whole structure will pulled off. In many cases what we normally do is, if you are unable to penetrate that much longer, then you actually do a anchoring of the pile into the ground, means you will drill a smaller hole. We will talk about one of the days I think later in one of the session about anchorage piles only for tension loading, which is very essential for such type of design. Then we have also lateral test, the static and cyclic, and you can see here static test is going to give you a certain capacity which will degrade when you apply the same loading several times, because the top layer of the soil, as we have learned from our PY curve, near the seabed you can see the soil gets disturbed quite a bit because of the repeated nature of loading and degrade the displacement or increase the displacement, degrade the capacity. So, we need to see after how many cycles the capacity gets reduced, that means you would see that displacement will be more. Then we have loading limit, whether to load to the ultimate failure stage, that means the pile will go into permanent deformation and the soil, or you want to do a routine test by which you will not destroy the pile, you will only do a extent of maximum working load the structure may get and stop it, so that the same pile can be used for permanent construction as part of the structure. So, either way we can decide. Only problem is there is an uncertainty in this second one, you do not know what behavior it will go through after it achieves that so called working load limit, because it can fail straight away, plastic deformation can happen, or it can have a redundancy after that, which will not be revealed when you do the working load test. Whereas, when you do this you will be able to find out at what load the pile is failing, then you know what is the factor safety, because the factor safety is defined as the ultimate load by working load or ultimate capacity by working load. So, you will only be able to ascertain the factor safety if you are able to find the ultimate load. What you will not be ascertain that factor safety, because in the working load test you only have that level, it may actually fail after just going slightly higher than the working load, which will not give you the comfortability of the factor safety. So, that is why the working load test is normally not preferred, but then cost versus your factor of safety and design requirements, you have to decide how many number of piles you want to do ultimate load test and how many you will do a working load test. But of course, if the test results show large scatter, then you will increase the number of piles that you do testing. If you do a 5 piles and all 5 of them shows very reasonable matching of results, then you may actually conclude that no further testing is required. But each one of them shows different results and different variations in displacement characteristics, you may actually decide to do a further more addition to the pile testing. which again is actually a procedure that you to be decided by the site representative. I think we have discussed the purpose is design validation. I think the primary purpose is design validation. Whatever the assumptions you have made during your borehole and to the design stage, you would like to validate that those assumptions are nullified, so that your process of construction can go. Quality control for sure in concrete pile is one of the biggest worry. In fact, steel pile you do not have such issues, but the quality control of concrete pile construction, because everything goes underwater, you have to displace. I think we have discussed about the construction of concrete pile. You have to displace the slurry which was poured inside by means of a good quality concrete, but the quality could not be ascertained because nobody can go inside. So, when you do this kind of low strain dynamic testing, you could also assess the concrete the honeycombing structure. If the concrete is not done properly, you will see the reflected wave will differ from the solid concrete that if you have. So, you can actually have testing of pile itself, whether the pile is sound enough to reflect and transmit the waves, or if the pile has got hollow honeycombing inside also can reveal. Similarly, for steel piles, if the pile has been broken during driving, and if you do this testing, and it will reveal that if the stress waves are not coming, you could easily find out where is the fault. So, that is the idea behind this, the low strain dynamic testing. So, basically quality control of the construction itself can be verified by means of carrying out cross correlation test. Sometimes you do a design development, you basically you have a large number of, some projects have thousands of piles, like if you go to some of the large scale industrial projects, you may have several hundred piles. So, you do a representative pile testing and use that information to further develop and then come up with a design procedure. In many cases, if you look at some of the large scale projects, they actually develop a new design procedure specific to the site, and using the design data collected from the pile load test plus the borehole information, and they come up with their own design strategy. And you do not need to follow the standard procedure given in either any of the codes or regulations, because it is proved by testing at the site. So, that will be done sometimes, and many cases always you will use it for further refinement of academic interest. I think these are secondary, but of course insufficient site investigation. Normally you do not do a construction without a site investigation, but then all depends on the owner's intention. Sometimes some government organizations may not be able to do a site investigation before the award of a contract to a contractor, because of the nature of limitations they have. They may not be able to allocate a fund separately for site investigation and separate for construction. It's part of the construction itself. So, what happens is, when a contractor comes to the site, they have no clue what is the soil. So, they will be doing the site investigation. So, that is the time when the design becomes difficult. The design has to be evolving based on the available information, but not actual site information. Many cases that happens. So, you do that at that time when the project starts. You have assumed certain parameters during your design, and then you proceed with the construction, but then do the testing first. Once you do the testing, your assumed information can be verified, and several other limitations on basically cost is one of the primary parameter. Nobody wants to do testing. If they can live with the engineered design, I think everyone will be happy, but that will not be the. Now, guidance from handbook of pile load testing just give you an idea of how you decide how many piles is good for a particular site. Just of course, this is only a guidance. It will needs to be decided by the site engineer and the owner, of course, for sure, depending on how much of time and money is allocated for that purpose. But typically, you can see the complex or very much unknown ground conditions. It's isolated place, no one has constructed in the vicinity. So, then probably you can go for a large number of. So, you see here what they recommended is one preliminary pile test for 250 piles. So, that means preliminary means this pile will not be allowed to be used in the permanent construction. So, you do a separate pile at a isolated location within the periphery of the boundary where the structure is going to be built. It will not be within inside, because what you do not want to fail the soil within close vicinity of a working pile. For example, you have a pile here and just half a meter away or 1 meter away you want to construct a pile and fail it, which is not very good, because you can't install another pile in the vicinity because the soil already have mobilized its full strength and failed. So, normally you will go a little bit away, but not very far. You can't do the testing several kilometers away. It does not represent the actual site conditions. So, within the perimeter, probably representative location, you will do a one preliminary test for 250 piles. So, you can see here it is only a guess, there is no rule book, or it is not representing some kind of relationship. It is only a guess that it may actually give you some information, plus one working pile test for every 100 piles. That means among the remainder of the piles, every 100 piles you select one and then do a, where the ground conditions are very much unknown, probably not very clear, no previous pile test data is available in the site, new piling technique is used in case in that area every time they were using a concrete pile, but suddenly you are going to use a test, you are going to use a steel pile, then it's an unknown experience, very limited information available. In such cases you do this, whereas if it is the other cases, your risk is reduced with reasonable information, then you can increase the or decrease the number of piles per testing. So, you see here one preliminary test for 500 piles, which, and then for very low, or in fact you got plenty of data, then you can also use 1 in 500, 1 in 100 or 1 in 200. In fact, codes are not suggesting any of these numbers, because they leave it to the the owners or the consultants who are representing the design validation. So, normally we design something very similar like this, 1 in 250, but not many projects will have 250 piles, maybe 10, 20, 50. So, if you do one pile, that itself is good enough. So, this is only a guidance which, if you are representing your company for pile testing, or if you are writing a specification for pile testing, you can put that kind of number. Rabbit load test versus dynamic load test, the kind of capacities that you expect, 30 meganewton is 3000 tons, and what kind of hammer you will be using, just information that you can use it, that much is practically possible to do the testing. So, if you remember, we were talking about pile capacity in offshore pile system. I think we were talking about 20 to 30 meganewton for each pile, which is something like this. So, it is not that we cannot do, it can be done, but at a very expensive system design, because water depth is more and you want to design a reaction piles for such type of testing will become costlier than your jacket. So, that is where we avoid. I think we just now discussed about static maintained load test versus the static penetration test, or the so called constant penetration test. I think you can read some of the information about the past history, what has done, the maximum load what was achieved in the previous several years. It can be done to that much of load, 3000 tons. So, you will see if you go around some of the railway construction, I think MRT construction is going on. I think 6 months back, so many places they were doing pile testing for the pillars, the big pillars. You will see that a huge platform is built, and concrete blocks were stacked up on, each was about 600 tons. So, you can see that the bulkiness of that platform to load this 600 tons, because you calculate a 600 ton by either by sandbags or by concrete blocks, you will get 3 to 4 layers of concrete blocks will come. So, safe working load, ultimate load and design verification load sometimes differ from, we discussed about safe working load is the working load of the pile as per the design requirement. Ultimate load includes the factor of safety, that means either 2 or 2.5 or whatever the design factor of safety as per the design code. If it is a IS code, you normally use 2 or 2.5, whereas the API code we use 1.5 and 2. And so this is the test load that you will apply if you do ultimate load test. Sometimes design verification load is in between these two. We go 50% overload. Instead of failing the pile, we do a pile load test taking between the working load and the ultimate load, sometimes 25% higher than the working load. Still the pile can be reused because you are not failing it, but it is slightly overloaded just to see that how the behavior goes. Because if the pile fails immediately after reaching the working load after 5%, the factor of safety is not there anymore. So design verification load, it can be any one of them or it can be in between also. A typical onshore pile load test, we will just see the methodology how it is carried out. So you can see here this is a good ground conditions, means the ground at the surface is reasonably good. So we have a gravity based support system, something like this. You construct pillars, sometimes we actually use concrete blocks, simply put on 4 corners, make a steel beam, something like this, and just you have your pile previously installed which is going to be tested, and then with a prepared pile head, could be a concrete piece or a steel piece placed on top, and then you start stacking up your weight, because while you are stacking up, because people have to go up and load it, or your crane has to bring material and then just keep stacking up, and then you will place a hydraulic jack or jacks, 1 or 4 of them, normally 4 of them is used, and just jack it up. So what happens is, previously when it was loading is done, at that time no load is going to the pile, and safe, because for a longer duration you do not want to keep this condition, because if it topples or slides down to sideways, you will be putting big danger on the pile itself as well as the system. So normally you have this is called the Kentledge weight distribution system. This is feasible only when the ground conditions are good, number 1, and also the distance from to the pile should be sufficient enough that the load does not actually alter the soil conditions in the vicinity of the pile. Imagine if you do this and if the soil gets actually squeezed and get compressed, the pile capacity that you are actually going to measure is not going to be representing the actual site condition, because already the soil has been compressed and consolidated. So that is why you have to keep this support system quite away from the pile itself. So you have to keep it 3 diameter to 4 diameter away. So this Kentledge becomes actually very large depth girders. Normally you will see 2 meter, 3 meter girder spanning between the supports, something like this. So you have to keep it 10 meter away if it is a 2 meter, 3 meter diameter pile. So they will be away, so that influence of the reaction is not coming back to the soil. So this is a typical onshore pile load test, that using spread footing type reaction system. So that is the idea behind. So this test can be repeated. If it is a working load test, you just load, unload, load, unload, but load will not be applied in one single stage normally, because then you only get one load, one displacement relationship. So you actually divide the total load into say several steps. If it is a 300 tons, divide into say 5 or 6 steps, and put 300 into say 6 steps, means 50 tons first, and just look at the displacement, then go to 100 tons, wait for some time until the displacement becomes constant, then you take the displacement reading, go and put the further loading. So it is just done in steps, and then similarly you can do a unloading. So from 300 you come to 250 and 200 and so on. So you can see whether the loading path and unloading path is same or differing. If there is a plastic deformation, then you will see that there is a different load path from loading to unloading. So that also can be verified. If it is a soil condition that the top surface soil is not good, or it is going to just distribute the load very close to the pile that is being tested, then you may actually look at installing additional piles, and this is the case, most of the cases it happens like this. So you install additional number of piles in and around the test pile. Normally 4 number of piles are installed, and you prepare a Kentledge, which is nothing but just a grid of beams which will support these weight during stacking during unloading process, and then when you want to do the testing, you simply use the hydraulic jacks to activate and then lift it off. So, you can see the difference between soft bound soil condition at the surface to good soil conditions, the expenses increase several fold. You can see here just only a simple pedestal support, quick to make, easy to remove, whereas when you go to this one, you can see here for one pile load test you are installing 4 number of piles. So, you can see the multiplication of the time and the cost and the removal. You have to remove these piles, you can't leave them there itself unless it is an isolated place. So, basically the procedure is same, only the difference is depending on soil conditions, you will do the support reaction and cartilage frame according to the requirement. And if you are going to do the same testing in coastal waters, 5 meter, 10 meter, 15 meter, 100 meter water depth, can we do this? So, that is where we bifurcate into a different idea. If it is a 20 meter water depth, yes, probably you can design a pile which will be erected around the load testing pile and make a platform something like this, and then construct this frame, load and unload can be done up to say 10 meter, 15 meter, 20 meter. But when you go beyond 25 meter, you will easily see that the diameter of the pile tested and the diameter of the support frame, the diameter becomes too large. If you actually have to do a pile test in say jacket location, 100 meter water depth, jacket is still not there, because jacket will come only after you complete all your design and everything. You can't do a testing of a pile through a leg, for sure it is impossible. So, when you want to do this 100 meter water depth, imagine you may have to actually specially fabricate a jacket, vertical in nature, isn't it, something like this, and keep the frame there and put the pile inside and do the testing. That means it becomes another project. So, that is why this pile testing is completely not feasible. So, maximum pile testing I think for coastal areas people have done up to 20-25 meters maximum, beyond which you will see that the design of the system itself becomes a problem, especially when you are doing so much loading. Coastal areas 300, 400 tons, 500 tons, but for jacket type of structures, if you want to mobilize weight of 3000 tons, which is becoming a bigger problem. So, how to avoid, even in coastal areas, even in land based structures, can we do testing without this weight? This is one of the very good idea, so that you can avoid, for example, if I go and connect this beam with this pile, so what will happen? I do not want to put the weights here. So, instead of using this weight as a reaction, what we want to do is we simply weld this beam with this pile. So, what happens when you are actually pushing up the hydraulic jack, the reaction will come from the soil itself. So, that is basically the idea. In the recent times, no one wants to do this is called a dead weight method of testing, and just you can eliminate that so much of weight, bringing the weight, stacking upon and removal can be removed, provided these piles which was installed as a reaction pile or a support pile has sufficient pull out capacity. Otherwise, that pile will come and you do not know whether you are measuring this displacement of this pile or whether you are measuring the pull out of the other pile, which will become a very complicated situation. So, that is where some still